What's going on, guys? Welcome back. Patrick here, and in this next section what we're going to talk about is the normal distribution. And I introduced the normal distribution, briefly mentioned it when we talked about density curves, and that's what a normal distribution is. It's basically a type of density curve. So to do a quick little review of what a density curve is, I mentioned that a density curve is basically like a relative frequency polygon with infinite intervals. And so what's going to happen is we're going to have some kind of measure on the x-axis of some kind of quantitative variable. And then on the y-axis here, we're going to have a proportion, or sometimes there'll be percentages, but in more cases than not, it's usually proportion. Now, when they show density curves in certain textbooks or normal distributions, a lot of times this y-axis won't be showed. Sometimes it'll be like invisible almost. So I'll just put like a dotted line there. Sometimes it won't be there. So a density curve, for example, is going to look like this. And this is actually how the normal distribution is going to look like, but we'll get into talking about a normal distribution in a sec. So this here is a density curve. Right, and we also talked about how density curves can have different skewnesses, so it could be skewed to the left, to the right, it could be symmetric. We also talked about how there could be multiple peaks. So this one here is a unimodal distribution, unimodal density curve, because there's one peak, but there could be a bimodal, there could be two peaks, for example. We also talked about the measures of central tendency, and how they relate to skewness, so how that mean mode and median relate depending on how the density curve is skewed. We also talked about that a density curve, the area under it is always going to equal 1. Or if this is in percentages, 100%. But again, it's usually in proportions, so the total area under the curve is going to be 1. Right, so that's just a quick review of a density curve, and a normal distribution is basically a type of density curve, and it has 3 characteristics. A type of density curve where it is symmetric, meaning it looks like this, and more specifically, symmetric talks about those measures of central tendency, how the mean is equal to the median, which is equal to the mode. Another characteristic of a normal distribution is that it's unimodal. Okay, and what that specifically means is that there's a single peak, or there's a single mode, right? A single peak like this, single mode. And then number 3, the third characteristic of a normal distribution, type of density curve, that is bell-shaped. So notice that this here has sort of a bell shape. And the reason why this specifically has to be mentioned for a normal distribution is because there's actual density curves, there's other distributions that fit these 2 characteristics. They're symmetrical and unimodal, but they are not bell-shaped. A good example of that is a density curve or a distribution called the Laplace distribution. It kind of looks like that. So notice that it's symmetrical, right? The mean, mode, and median are going to be equal. It's unimodal. It has a single peak up here, but it's not bell-shaped. Right? This doesn't have the shape of a bell. This here does. And that's why that third characteristic for a normal distribution is usually mentioned when it's introduced. Now, if you remember, when we talked about how data can be described, it can be described in 2 ways. We could look at the central tendency, and more specifically with normal distributions, notice when we've been talking about some of these characteristics that a normal distribution has, we've been talking about the central tendency. So for example, when it's symmetric, it means that the mean, mode, and median are the same, or if it's unimodal, it means that there's just a single mode, and all of those are measures of central tendency. But there's another way. There's another part of describing data, and that's describing a data's variability. And we have to talk about variability as well when we're talking about a normal distribution, because you can run into different kinds of normal distribution. So for example, you could have a normal distribution that looks like that. This is not maybe as symmetric, but it could look like this, or we can have a normal distribution that looks like that, right? Notice that both of these fit these characteristics. They're both symmetric, they're both unimodal, they both have single peaks, and they're both bell-shaped. But notice that they look very different. This one here is less wide. This one here is more wide. And so what that means when it's more wide is that the data is spread out more. And so when we say more wide, more specifically, what that means is that there's more variability. While here, there is less variability. Okay, and we talked about variability. We had a section for that. We talked about different measures of variability. We talked about range, quartile, standard deviation. And more specifically, when we're talking about a normal distribution and we're talking about its variability, we're going to be talking about its standard deviation. That's the measure of variability. Out of those three we mentioned, standard deviation or variance sometimes is the one that's going to describe the variability of a normal distribution. While the central tendency, there's three measures of central tendency: mean, median, and mode. But when we're talking about the central tendency for a normal distribution, we're going to use the mean. And the median and the mode are going to be the same as the mean for a normal distribution, but usually we don't mention those other two measures. We usually mention the mean of a normal distribution. And so with these two measures, they both tell you the type of normal distribution you're going to be working with. These are the two characteristics, if you will, the two things that describe a normal distribution. And a lot of times you'll see mean be described by the Greek letter mu, right? So you'll have this describing the mean. And then standard deviation, a lot of times it will be described with the Greek letter sigma. And so sometimes in statistics, when people are talking about data, they'll be like the sigma of the data. And what they're saying is the standard deviation of the data. And so what we're going to cover in the next video is we're actually going to go into a little bit more detail about the standard deviation, and more specifically how it applies to the normal distribution and what it actually tells us about the data, both technically and I'm going to visually show it on the density curve as well.